Hello friends, and once again a very warm welcome to the session where we are together going to solve the question based on the JEE main pattern for the chapter Atoms. So far we have covered the session which was dealing with the chapter Atoms and which were dealing with the question based on the CBSE pattern. Now we are going to solve the question based on the JEE main pattern. And as you know, the question paper will be comprised of number of sections where you are going to see the comprehension type question, the assertion and reason type question, only one option correct type of options, type questions, and more than one correct type options, and match the following options and true, false, and so many options, right? So we are having different number of sections in this paper. Together we will be here to solve this question paper, and let's just see what is the question number 1 before us. So first of all, you can read the instruction. We are here having question number 1 to 3 in which only one option would be correct. So from question number 1 to 3 we will be having 4 options with us. From that we have to choose only one correct option, right? So first question says that the ratio of the maximum wavelength of the Lyman series. So let me just show you. This is talking about the Lyman series in hydrogen spectrum to the maximum wavelength of Paschen series. Now you have to just notice out one thing, that we have to find the ratio of the maximum wavelength, isn't it? Now if you are forgetting one thing, what do we mean by Lyman series and Paschen series, let me just introduce you once again. We will just take a quick revision of what we have covered in the theory of this chapter. Suppose this is the ground state, say this is n equals to 1. I am going to draw the energy levels before you for the hydrogen spectrum. Say this is n equals to 2, this is n equals to 3, this is 4, 5 and 6. Now to all those lines which will be falling into the final energy level 1 will be called as Lyman series. Let me just say that if an electron was initially at energy level 6, if it is coming and falling to the energy level 1, and if the electron is coming from 5 to 1, from 4 to 1, from 3 to 1 and from 2 to 1, all these series in which the electron is falling into the energy level n equals to 1, these lines will be called as Lyman series. So what is this? This is Lyman series. Basically in this question we have to deal with the Lyman series and another one as Paschen series. So the Paschen series is that in which the final energy level will be n equals to 3. You would have learnt about the Balmer series where you would have seen the energy level, where the energy level is finally 2, the series will be called as the Balmer series. But in this question we have to deal with, since Paschen series where n2 equals to 3, that means your final energy level will be 3. So let me just draw these lines. From initial level n equals to 6 to n equals to 3. From initial level n equals to 5 to n equals to 3. From 4 to 3. Similarly, whatever will be your energy level, when your final energy level will be n equals to 3, that will be your Paschen series. So now let us just see what has been asked in the question. We have to find the ratio of the maximum wavelength of the Lyman series and the Paschen series. Now we are having a formula with us. That formula is again an important formula, because we know that whatever is the question coming out from this chapter, this equation will be definitely going to be used. So 1 by lambda equals to Rz square 1 by n1 square minus 1 by n2 square. Here your n1 will be for the Lyman series. If I will be talking about the Lyman series, what will happen? Your final energy level is n equals to 1, right? So for the Lyman series, n1 equals to 1. Now, because we have to find the maximum wavelength. For the maximum wavelength, you just have to remember one thing, that whenever your electron is coming from the nearest energy level to the Lyman series, suppose, because I am talking about the Lyman series where n1 equals to 1, that means your final energy level is 1. Your initial energy level, if n equals to 2, if this is your initial energy level, then there will be the maximum wavelength of the photon of the electron that will be coming out. So that means lambda max will be that wavelength of photon when the electron will be jumping from the nearest energy level to n equals to 1. Similarly, we will be doing for the case of Paschen series, because in the Paschen series we are having n1 equals to 3. So the maximum wavelength will be that case when the electron will be jumping from n equals to 4 to n equals to 3, isn't it? So here will be the maximum wavelength. Let us just take first of all the case of Lyman series. So in that case, for maximum wavelength, n2 equals to 2, right? Now let me just put this value into the equation. We will be having 1 by lambda L, because we are having for the Lyman series, so I am writing this as lambda L. That would be R into Z square. Now because we are talking about the hydrogen spectrum, for the hydrogen Z will be equals to 1. So we will be definitely writing over here as R only. So 1 by n1 square. So 1 by 1 minus 1 by n2 square. 1 by 2 square, that is 4. Now you are having your lambda L as 3 by 4. That means this was coming out to be 1 by lambda L. If you will talk about lambda L, that will be 4 by 3R. Now this is the wavelength for the Lyman series, the maximum wavelength. Note my word, I am speaking about the maximum wavelength, right? Now if I talk about this was for Lyman series. If I talk about the Paschen series, let me just write over here. You know that for the Paschen series, we know that for Paschen series, n1 equals to 3 and n2 will be definitely 4, because the maximum wavelength will be that wavelength when the electron will be jumping from n equals to 4 to n equals to 3. So that means n1 equals to 3 and n2 equals to 4. So we have to put these values into this equation and then we will be having the solution. Let me just draw for this. 1 by lambda for Paschen series will be equals to R into 1 by n1 square. Here n1 is 3. So we will be having 1 by 9 minus 1 by 4 square. That means 1 by 16. Now if you will be solving this, you will be having as 7 by 144. Right? Now because we have to find the lambda p, so this was 1 by lambda p. Your lambda p will come out to be 144 by 7R. Now you are having these two with you. Lambda L equals to 4 by 3R. And lambda P as 144 by 7R. What has been asked in the question? The ratio of these two. The ratio of the maximum wavelength of the Lyman series to the Paschen series. So we can just find out the ratio by putting that lambda L by lambda P. So lambda L by lambda P would be equals to 4 by 3R divided by 144 by 7R. So that will be 7R divided by 144. R cancelled, and this will be multiplied divided by 4 by 32 times. So now if we will be multiplying this, you will see that this will come out to be 108. This is not, this is 36 times. So your lambda 1 by lambda L by lambda P has came out to be 7 by 108. Now let us just see whether there is any option available in the question or not. So let us just move towards the question and see, is there any option? Yeah, I can see that there is an option number D, the D option, 7 by 108. So this is the correct answer. You can just note it down and then we will be beginning this, right? So as we have covered the first question of this session, now let us just move towards the second question and let us just see what does the second question says. Okay, so we are having one figure before us, and from that we have to tell them, because in this figure you can see that energy levels has been given. So from here what we have to tell, some energy levels of a molecule are shown in the figure. Yeah, we can see here, and we have to tell them the ratio of the wavelength R equals to lambda 1 by lambda 2. So that means we have to tell them the ratio of lambda 1 to lambda 2. You can see here this is lambda 1 and this as your lambda 2. Now let us just see, this is your lambda 2 and this is your lambda 1. What we have to now do is we have to find their ratio. Okay, so we know the one formula how to find the ratio of the wavelength, or basically we know that how to find the energy. If we know the energy, we can directly find out the wavelength, because E equals to h nu and nu equals to C by lambda. So that is a very basic thing that we all know. Now let us just start the question, because we are having, you can see here, this is minus E, this is minus 4 by 3E, this is minus 2E, minus 3E. Now what we have to note over here is that, because if I am going to talk about this lambda 2, in this case you can see the electron is jumping from this minus E to minus 4 by 3E energy level, and if the wavelength is coming from this energy level to this energy level, so you can see here it is coming from minus E to minus 2E. We can just write over here as that E1 equals to, basically I am dealing with the lambda 1. So I am talking about the E1. E1 would be, because electron is taking transition from minus E to minus 2E, so that will be minus E minus 2E, isn't it? Because energy is what? The difference of the two energy level. The difference of the two energy levels will be the wavelength of the photon emitting out. So that is why we have written this. This is the difference of the two energy level, and this is the wavelength, this is the energy of the photon of the wave that is coming out. So we can write over here as hc by lambda 1 equals to minus E, minus minus will become plus, so 2E minus E as E. You are having your energy for the first wavelength as E. Now from this equation I can find out the lambda 1. So your lambda 1 will be hc by E. let us just consider this as equation number 1. Let me just now talk about the lambda 2. For the lambda 2, you can see here the electron is coming from minus E to minus 4 by 3 E. So for this, E2 will be minus E minus 4 by 3E, isn't it? Now if you will be seeing that, you will see this will become as 4 by 3E, and this E2 will be your Hc by lambda 2, because we are dealing with the second wave, so we will be writing it as Hc by lambda 2. Now from here you can have your energy as minus 3E plus 4E, that will be E. So you are having your Hc by lambda 2 equals to E by 3. From here you can find out the wavelength. Lambda 2 will come out to be 3 Hc upon E. Now because you have to find the ratio of lambda 1 and lambda 2, suppose this is the equation number 1. As we have to find out R, what we will be doing? We will be just finding out the ratio. So the ratio, that is R equals to lambda 1 by lambda 2. In the question I can see that this is we have to find. So lambda 1 is Hc by E and lambda 2 is 3 Hc by E. I have written the multiplication sign because I am just taking the reciprocal of this. So lambda 2 will be what? Lambda 2 will be 3 Hc upon E. So that means E upon 3 Hc. We can cancel them out. Hc cancelled, E cancelled. So that means you are having your R, the ratio of lambda 1 by lambda 2 is equals to 1 by 3. Now let us just see whether there is any option in the question or not. Because we have to choose only one correct answer, so your answer must be accurate. So from these given options, I can find out that option number D is the correct answer. So yes, because we have started with the correct approach, we have just succeeded to gain the correct answer, right? So this was the approach how to reach to this destination. Now let me just scroll the question and just see what is the question number 3. Alright. So the question number 3, what I can see before me is hydrogen, deuterium, singly ionized helium, that is 2He4 plus, and doubly ionized lithium all have one electron around the nucleus. Consider an electron transition from n equals to 2 to n equals to 1. So that means the transition has been given same for the all, n equals to 2 to n equals to 1, right? So if the wavelength of the emitted radiations are lambda 1, lambda 2, lambda 3 and lambda 4 respectively, what will be the approximate answer? Approximately which one of the following is correct? So let us just find out what is lambda 1, lambda 2, lambda 3 and lambda 4. Basically, we know that again the same formula, 1 by lambda equals to R into Z square 1 by N1 square minus 1 by N2 square. Right? Now if I am talking about the first case, that means the hydrogen, let me just consider it as 1. I am giving it number 1. Then I will be giving it deuterium as number 2. After that, we will be dealing with singly ionized helium, that is 2He4 plus. I will be giving this as number 3. And number 4 will be given to this doubly ionized lithium. So that means lambda 1 will be dealing with hydrogen, lambda 2 is for deuterium, lambda 3 will be for the ionized helium and lambda 4 will be for the lithium, right? So now let us just begin the question. We are having one formula with us, that is 1 by lambda equals to Rz square, 1 by n1 square minus 1 by n2 square. I am now considering the case number 1, that is for the hydrogen. For hydrogen, Z equals to 1. Everyone knows that, right? So let me just write 1 by lambda 1, because first of all we are dealing with lambda 1. For the hydrogen, 1 by lambda 1 equals to R. Z is 1, so we are writing only R. Now 1 by N1 and N2. In the question, what I can see here, transition has been given from n equals to 2 to n equals to 1. So that means final energy level is n equals to 1. We will be putting it as 1 by 1 square minus 1 by 2 square. Right? So now we are having 1 by lambda 1 equals to R, 1 minus 1 by 4, that is 3 by 4. You are having your 1 by lambda 1 as 3R by 4. Or from here you can write it as lambda 1 equals to 4 by 3R. Okay, so this is the case of hydrogen. Now let me just begin with the second case, that is the for deuterium. Now let me just tell you what is deuterium. Deuterium is the isotope of hydrogen. It can be written as 1H2. That means again for this Z will be equals to 1. Right? So that means if you will be putting the same, you will gain the same answer. Let me just write, this is for lambda 2 and this will be again R1 minus 1 by 4. So you are having 1 by lambda 2 equals to 3R by 4, or lambda 2 can be written as 4 by 3R. That means lambda 1 has came out to be equals to lambda 2. Now let me just see in the question whether there is any option where we can see lambda 1 equals to lambda 2. So yeah, I can see that in the very first option I can see lambda 1 equals to lambda 2. But I am not saying that this is the correct answer. I gained two things, lambda 1 and lambda 2, and they are coming out to be equal. For lambda 3 and lambda 4, I have to do the rest part. I will do it, but just for the sake of convenience, we are checking it out whether we are going into the correct way or not. So this was the lambda 2. This is our lambda 1. If I talk about lambda 3, that means for ionized helium. Now for helium, we all know that Z is 2. For this Z equals to 2. So let us just put this value of Z into this equation. So we will be having 1 by lambda equals to, this will be lambda 3 because we are dealing with the third part now. So 1 by lambda 3 equals to R into Z square. Now Z is 2 square, 1 minus 1 by 4, because transition is same for all. So we will be having 4R into 3R by 4. 3 by 4. So basically we are having 1 by lambda 3 as 12R by 4, isn't it? From here you can write it as lambda 3 equals to 4 by 12R. Now let me just see for the fourth case, that is the case for lithium. We know that for lithium Z equals to 3, right? So now we are going to put this value again into this equation to gain the value of wavelength. So 1 by lambda 4 equals to R into Z square, 1 minus 1 by 4. So that means 9R into 3 by 4, or you can say your lambda 4 has came out to be 4 by 27R, right? Now because we have to find out the relation, what I can see over here, lambda 3 has came out to be 4 by 12 R. That means lambda 1 was 4 by 3. Lambda 3 is 4 by 12. So if you are going to see that lambda 1 by lambda 3, you will be having 4 by 3 R into 12 R by 4. That means 4 times. Lambda 1 is 4 times of lambda 3. Let me just see whether there is any option. Yes, I can see that lambda 1, lambda 2 equal. Lambda 1 has equals to 4 times of lambda 3. Now let me just check whether this is also correct or not. Because now we have to tell in the basis for lambda 2 and lambda 4. So let us just compare here only. Lambda 2 is 4 by 3 R. Lambda 4 is, what was lambda 4? Lambda 4 was 4 by 27 R. You can see from here. So we will be having 4 by 27 R. So lambda 2 by lambda 4 will come out to be 4 by 3 R multiplied 27 R by 4. 4 cancelled, R cancelled, this has came out to be 9. Now that means lambda 2 is 9 times of lambda 4. And yes, this is the correct answer because lambda 2 has came out to be equals to 9 times of lambda 4. So that means we were having the correct answer by looking at these two also. But for the correct approach, we have done all the options. And so finally, we have concluded that this option is the correct answer, right? So we are done with this question now, and now we will be looking at the question number 4 of the session. Let me just proceed with this. Okay, so the directions of the question has been changed now. From question number 4 to 5, we will be having multiple correct answer. That means more than correct answers. Okay, so we will now read the energy, the magnitude of linear momentum and orbital radius of an electron in a hydrogen atom corresponding to the quantum number n are E, P and R. This is E, energy, magnitude of linear momentum as P, and orbital radius of an electron has been given as R. So this has been given in the question. Then according to Bohr's theory of hydrogen atom, we have to verify all these options. Now if I'll tell you one thing, because you have covered this chapter in your theory, so you must be learnt with all the formulas. What is the formula for the radius of the orbit of electron? You must be knowing that. What will be the formula of energy? You must be knowing that. I am not going to tell you the complete formula, but I will definitely write the relation between the quantum number and this corresponding values. So let me just begin. We know that first of all, if I talk about the energy, energy is inversely proportional to n square, because you know that the formula for energy is 13.6 upon n square. So definitely E is inversely proportional to n square. Equation 1. Second thing, the linear momentum. Linear momentum can be written as P equals to mv, right? And we know that in the velocity formula, V is inversely proportional to n. So can I write this as P will be also inversely proportional to n? Because we know that V is proportional to n and P equals to mv. So definitely P will be also inversely proportional to n, because if you are going to put the value, you will be having m into 1 by n. Say I am writing it as 1 by n. So you can look at this, that P is also inversely proportional to n. We are now having second relation with us. To just look at the third, orbital radius. We know that orbital radius, that is R, is directly proportional to n square. These are the relations that we are knowing from the heart, because this is the core of the chapter. This is the core of the atoms that you must be learning. So now, because now I am having all these relation, I have to tell them whether EPR is proportional to 1 by n or not. Let me just check all these options one by one. What we will do now, we will do the product of E, P and R. We are dealing for the first option, EPR. Let me just put these values. E is proportional to 1 by n square. P is proportional to 1 by n. And R is proportional to n square. So if you will see here, we can cancel out n square, and so we are having EPR as 1 by n. Or you can convert it into the proportional sign, because this is not equal, but these are proportional. Now we are having EPR as proportional to 1 by n. So let me just see whether it was there in the option or not. So yes, because they are also asking us the same, that means this is the correct one. EPR has came out to be proportional to 1 by n. Now let us just see all those options that has been left. P by E is proportional to n. So we will now do for P by E. P by E, that means P was inversely proportional to 1 by n and E was proportional to 1 by n square. Okay. So now let me just see here, 1 by n and energy was proportional to 1 by n square. So we can just write over here as 1 by n square. Now you can see this is 1 by n square. When they will be multiplied, we will be having n square by n. That means what? You are having n with you. That means P by E is proportional to n. Has this came out to be true or not? We can see in the option what has been given. So yes, this has been asked whether P by E is proportional to n or not. Yes, this is proportional to n, because we have found out the same relation, right? Now whether it is the third option is correct or not, ER is constant for all orbits. So let us just do for the ER. This is the third part. So ER, E is what? E is 1 by n square. Let me just remove and put the proportional sign. This is 1 by n square and R was proportional to n square. So because here n square cancelled, we are having ER is proportional to 1. That means this is a constant value we have found as 1, and 1 is constant. So let us just see whether it is again asking the same or not. So yes, they are saying that ER is constant for all orbits. So yes, this is true. Again we can say this is the correct answer. Now to check for the fourth and last option, PR is proportional to n. So let me just do over here only PR. This will be proportional to, P was proportional to 1 by n. So put this value 1 by n. R was proportional to n square. So put this value. You can see this has came out to be proportional to n. So yeah, this is again the correct answer. So that means all the option of this question is correct, right? So now you can note it down. You can note all these formulas step by step, and then we will be begin with the next question. That will be the question number 5, right? So okay, in this question we have seen that all the options were correct. Now let us just see the question number 5, the next question. Alright, so now we are having another question before us, in which again we have to choose multiple number of answers, because this is the category where you can have more than one correct answers. Whether it can be 1, it can be 2, it can be 3, or it can be 4, as you have seen in the previous question, right? So question number 5 says that the wavelengths and the frequencies of photons in transitions 1, 2 and 3 for hydrogen-like atom are lambda 1, lambda 2, lambda 3, V1, V2 and V3 respectively. So that means wavelengths are lambda 1, lambda 2, lambda 3 and the frequencies are nu1, nu2 and nu3 respectively. Now because here we have been given the transitions between 1, 2 and 3, not for the hydrogen atom but for the hydrogen-like atoms. Now I will draw one thing before you. Say this is your n equals to 1, this is n equals to 2 and this is n equals to 3. Because transition is taking place from 1, 2 and 3. So in that case there are two kinds of transition. Whether the electron will be coming out direct from n equals to 3 to n equals to 1 or the transition can be from 3 then 2, from 3 to 2 and then from 2 to 1. So we are having two kind of transition before us. For this you will be having your lambda 3, this will be your lambda 2, this will be your lambda 1, right. Now we can write over here as, because this is the total transition, I can just write here as E3 will be equals to E1 plus E2. Because we can see here energy of the transition, energy of the photon that will be emitting from this radiation will be equals to the sum of the energy of these two transitions. So basically we have written this E3 equals to E1 plus E2 and we know one thing, E equals to what? H nu. So I can write it as H nu 3 equals to H nu 1 plus H nu 2. If you will be taking H as common, you will be having nu 3 equals to nu 1 plus nu 2. So this is the combination of the frequencies. Let us just see what has been given in the option. We can see here nu 3 has been given as nu 1 plus nu 2. That means this is the correct option. And nu 3 cannot be nu 1 nu 2 upon nu 1 plus nu 2. So this one would be incorrect. Now for the wavelength, because only one option can be correct among these two. Whether the nu 3 will be nu 1 plus nu 2 or whether it can be 1 by nu 3 equals to 1 by nu 1 plus 1 by nu 2. From this answer will be happening. But this will not be the correct option because we have seen that the frequencies has came out to be equals to nu 3 equals to nu 1 plus nu 2. Let us just now check for the wavelength. We know that nu equals to C by lambda. Yes. So just put this value into this equation. We will be having C by lambda 3 equals to C by lambda 1 plus C by lambda 2. Right. So if you will be taking C as common, you will be cancelling it out. Now you are having with you 1 by lambda 3 equals to 1 by lambda 1 plus 1 by lambda 2. Right. Now if you will solve this, this has become a very simple equation. If you are going to solve this, let me solve it here. Your 1 by lambda 3 will came out to be lambda 1 plus lambda 2 divided by lambda 1 into lambda 2. This is your 1 by lambda 3. Because I have to find the lambda 3, that would be lambda 1 lambda 2 upon lambda 1 plus lambda 2. Let us just confirm from the options whether it is correct or not. So yes, I can see here lambda 3 is lambda 1 lambda 2 upon lambda 1 plus lambda 2. So these both are your correct options and these are your wrong answer. So from these four options we have choose two correct answers, 1, A and D. Right. Now we are done with this question. Let us just move to the next question and just see what will be it. Okay, so the next category is we have to match these columns. we have to match these with the physical phenomenon. There are two columns before us, say table 1 and table 2, and in that we are having some phenomenon before us, and this phenomenon has some particular name, and these names has been given over here. We have to match them with the correct option, right? Now let me just tell you, it can be an option that answer A, the question A can be the correct answer for this. That is not mandatory that only one can be matched with the one. There can be 1 to 2 answer, right? So let me just begin with the option with the question part A, transition between two atomic energy levels. We know that when there are energy levels before us, many things can happen. If the electron is coming from here to here or from jumping from here to here, there are certain number of cases. First option, characteristic X-ray. Yes, definitely it can be happening. If you will be clear with the concept of continuous X-ray spectrum and the characteristic X-ray spectrum, you would have known that what happens in the case of characteristic X-rays. So that means if the transition is taking place, this can be the correct answer. So let me just write A over here. And for photoelectric effect, photoelectric effect cannot be considered in the process of transition of atomic energy levels, because we know that photoelectric effect is when the radiation is coming from and hitting the metal surface, some electrons will be getting ejected. So these are the electrons that is getting emitted. So this is not the transition between two atomic energy levels. This cannot be A. Let me just read for hydrogen spectrum. Yes, it can be happen because we have learnt about the hydrogen atom, hydrogen spectrum, and we know that in the case of hydrogen spectrum, transition of electrons takes place between the atomic energy levels. So yes, this can also be correct. So I am writing A over here. Now the fourth one, beta decay. Beta decay is what? Transition of electrons. Transition between two atomic energy levels cannot be beta decay. So it cannot be the answer for A. For the option number A, we are having P and R. So you can write here P and R are the correct answer for option number A. Now let me just consider the B part. That means the electron emission from a material. You can see here that in the case of characteristic X-ray, there is no emission of electron. So that means this is not the correct answer, the correct match. The photoelectric effect. In the photoelectric effect, you would have seen the electron is being emitted. So yes, this can be the correct answer. So I am writing over here as Q and here as B, right? Let us just confirm for the hydrogen spectrum. Electron is being emitted from a material. No, electron is not being emitted. It is just taking transition in the case of hydrogen spectrum. That means this is not the correct answer. And the beta decay. Yes, definitely beta decay. In the case of beta decay, the electrons are going to be emitted out from the material. So that means this is the correct answer. So we can write over here as QS and here I will be adding B. Now the C part, that is the Moseley's law. Moseley's law is directly related to the X-ray. So we can just put a C over here and a P over here. There is only one thing, that Moseley's law is directly related to the X-ray and not any other option. So that means only one option is correct for this. Change of photon energy into kinetic energy of electrons. This happens in the case of photoelectric effect because photon energy is being converted into the kinetic energy of the electron. This was the photon, h nu, and because of this h nu, electron is being emitted out with the energy that is half mv square, or you can say hc by lambda. So that means photon energy has been converted into kinetic energy. This happens in the case of photoelectric effect. That means only Q option is correct for this. So we can write over here as B and D. This is the match of these questions. Now you would just imagining that I was thinking that only one option can be correct. So my dear students, you have to focus on all the options that will be given in the second column of the match. You have to verify it with all these options. That can be happening that there can be more than correct options. So you have to verify with all the options. Now let me just move to the next part, the question number 7. This question number 7 is of different category, that is the assertion reason type question, where an assertion will be given to you, a reason will be given to you, and you have to tell whether both are correct and reason is the correct explanation for this assertion, whether both are false, whether both are true, and whether both are true but reason is not the correct explanation for this assertion. Let us just consider the assertion, Balmer series lies in the visible region of electromagnetic spectrum. You know that the formula for Balmer series is this. That means your final energy level is 2. And this is the very true thing that this Balmer series is the only series which lies in the visible region of electromagnetic spectrum. I have said you again, I am repeating myself because I have just said you in the theory class also, you have to learn the electromagnetic spectrum when you are going to attempt your question paper. This is the main important thing that you should be knowing, because you are going to be encountered with such questions and then you will be stuck here if you are not aware of the electromagnetic spectrum. So just mark this is important and you have to learn it. Just Google it, or you can make it from your textbook also. Paste it on your wall and just look at that regularly. Whenever you wake up, just look at the table and you will be learning it in the very easy manner, because this is the important thing. And this will be considered in all the parts, whether it is physics, whether it is chemistry. This will be considered in all the subjects, right? So this is the important part, and we know that since Balmer series lies in the visible region, that means this is the true assertion. This is true. Now let us just check the reason, because 1 by lambda equals to r 1 by 2 square minus 1 by k square. This is also correct, because for the Balmer series you can just see over here 1, 2, 3, 4, 5 and 6. All those radiation, all those waves that will be reaching to the n equals to 2, that will be lying in the Balmer series. So that means 1 by lambda, that means n1, final energy level will be 2. So that means this is the correct option. And k can be 3, 4, 5, because transition is taking from either 3, either 4, either 5 or either 6. So that means this is also the true statement. But yes, this is not the correct explanation of this assertion. It lies in the visible region because its wavelength lies in the visible region. This is not the correct answer. This is not the correct explanation. So what we can choose over here? We can say that both assertion and reason are true, but the reason is not a correct explanation for the assertion. So this is your correct answer, right? So you have to attempt such question in this manner. Let me just move towards the next question, that will be the question number 8. And yes, I can see from here that a new category has been now arrived before us, and this category is the comprehension type question. The comprehension has been given before us, and question number 8 to question number 10 will be based on this passage. An electron is orbiting in a circular orbit of radius r under the influence of a constant magnetic field B. Assuming that the Bohr's postulate regarding the quantization of angular momentum hold good for this electron. Now, what you have to observe over here, let me just move towards the question number 8. It has been given that radius of the nth orbit of electron will be what? We have to find the radius. Let me just tell you one thing. First condition that has been given in the question is this: Bohr's postulate regarding the quantization, and we know that quantization of angular momentum is mvr equals to nh upon 2 pi. Suppose this is the equation number 1, and also what you can see over in this question is this: the constant magnetic field B. Now the constant magnetic field B is that the electron will be revolving in the influence of magnetic field B. Now if the electron is revolving in the influence of magnetic field, that would be R equals to mv upon E into B. This will be the radius of the orbit in the influence of electric field, the magnetic field. Now from here what I can observe, since we have to find the value of radius of nth orbit. So the radius of nth orbit can be found out as you are having two equations before you, r equals to mv upon eb and mvr equals to nh upon 2 pi. Now because we have to find the value of r, I can just put the value of mv from here and bring this out into this equation. Let me just write mv will be equals to nh upon 2 pi r. And I am going to put this equation here. So my r will be equals to mv upon eb, we will place in place of mv. So that means nh upon 2 pi r into eb. So from here you can see r square equals to nh upon 2 pi eb. That is r equals to nh upon 2 pi into eb. Let us just now check whether this is the correct option or not, because this is the radius for the nth orbit. Rn equals to under root nh upon 2 pi eb. Yeah, so B option, that means r equals to under root nh upon 2 pi be is the correct answer for this. And this is the correct approach for this, because two conditions was given in the question. First was this and second was this, right? Now let me just see the question number 9. Okay, so we have to find the kinetic energy of the electron in the nth orbit. So we know that the kinetic energy is what? Let me just, okay, so the kinetic energy, let me just start from here, because we are having our radius as under root nh upon 2 pi eb. Now from here, first of all I have to find out the velocity, because kinetic energy is half mv square, right? So to find out the velocity, what I can do from here, I will be again using these two equations. Earlier I have found out the value of mv. Now what I will do, I will find out the value of r and will put into this equation. Or I can just directly put this r into this equation, putting 2 into 1. We will be having mv into r, that is mv upon eb equals to nh upon 2 pi. That means you are having with you as m square v square upon eb equals to nh upon 2 pi. Or you can see here v square will be equals to nh eb upon 2 pi m square. That means your v has came out to be under root nh eb upon 2 pi m square. Right? You are having your velocity before you as this. Now because we have to find out the kinetic energy, this will be half mv square, so half m into v square. So you can just do the square, you can just directly put this value over here, that will be nhEb upon 2 pi m square. So this m cancelled and we are now having nhEb upon 4 pi m. This is the value of kinetic energy. Now we have to verify whether this is the correct or not. nhEb upon 4 pi m. So just move. Okay, I can see that option number A is the correct answer for this. We also have reached up to the kinetic energy as nhBe upon 4 pi m. Right? So this is the correct answer for this option, for this question. Now let us just move towards the next question, that will be the question number 10 and the last question for the session. Now just see what is the question number 10. We have to tell them the potential energy of interaction between the magnetic moment of the orbital current due to the electron moving in its nth orbit and the magnetic field. So we have to tell them the potential energy. And let me just tell you what has been given over here as magnetic moment. Magnetic moment is what? It is denoted by m equals to I into A, capital M it is. Finally, what I have to find in this question is potential energy, that is U, and U is denoted as minus mb cos theta, right, where theta is the angle between magnetic field and the what is this, magnetic moment. Now to find the m, I am having m equals to Ia. I is what? The current, and current is charge per unit time. So I can write it as m equals to E by T into A. Because the electron is revolving in a circular orbit, so I have to write the area as pi r square. Now we know that time is what? Time is distance upon speed. So I will be writing it as 2 pi r upon v, because time is distance upon speed. So put this value into this t, you are having 2 pi r by v into pi r square. Now what you will be having? Pi cancelled, r cancelled, you will be having EVR upon 2. This is the value of capital M. Now because we have to put this value here and we have to find the value of potential energy, what we can do over here is we are having M as EVR upon 2. We are what we just have to do over here, put the value of V and R what we have found in the previous question. We have found out the value of kinetic energy and velocity. So I have just removed it from here. Your velocity would came out to be, let me just see, half mv square. So that means this was your velocity. 2 pi m square. Now this was your velocity that has came in the previous question, and let us just see what was the radius that was coming out. Let me just move to the first question. It was something that under root nh upon 2 pi be. I think this was the correct answer. So now we have to put this value of r, this was the value of r, and this is the velocity of v. We have to put both these values into this equation, and then we will be having the value of magnetic moment. So put this value, v is equals to under root nhEb upon 2 pi m square into the value of r. R is under root nh upon 2 pi into be, right? So that means what we are having with us, okay, this is E by 2. Now what we are going to do, under root nh into under root nh, that will be nh, right? Under root 2 pi multiplied by under root 2 pi. So that means simple 2 pi. Under root m square will came out to be m. Under root be, they will be cancelled. So we are having with us as ENH upon 4 pi m. This is the value of magnetic moment. Now what we have to do is, we just have to put this into the potential energy. What was the formula for potential energy? It was U equals to minus mb cos theta. Now the question arises, what will be the value of theta that we are going to put here? Because there is nothing that has been given into the question, so that means we have to find out the maximum value of energy. And you know that the maximum value of energy can be only when theta will be equals to 180 degree. Because cos theta, that means cos 180 is minus 1. And if you are going to put this value into this equation, this term will become positive. That means this will be the maximum value of potential energy. So what we are going to now put, U equals to minus mb, what is the value of m? ENH upon 4 pi m into b into cos 180 degree, that is minus 1. So you are having U equals to ENHB upon 4 pi m. Let us just now verify whether the option is available or not. ENHB upon 4 pi m. Okay, so now let us just see what was the question. Okay, so yeah, I can see option number 4, the D option is the correct. ENHB upon 4 pi m. So this is the correct answer for this question. So yeah, we have now done this question and we have completed the session with 10 questions based on different sections for the JEE main pattern. We will be meeting again in the next session where we will be solving together the JEE advanced pattern. Till then, just keep practicing, just keep revising what we have covered. Just take care of yours. Bye-bye.